Okay, so today let me just to revise what we discussed last week till now. So we discussed about the SAP work process, jobs, printers, schools, right? And also client administration. Last week we discussed, right? So that is what we discussed up to now. So and now let's discuss SAP architecture once. Okay, now you will understand how the SAP architecture will be. Okay, so the architecture, SAP architecture, right? So SAP is the three-tier architecture, right? SAP is the three-tier architecture. So it should be like, suppose SAP architecture. SAP is the three-tier architecture. So suppose like these all are the user PCs. Means you guys are logging in here, right? You all are here, right? You all are here. From here, you will connect to the SAP application server. This is the SAP application. You will connect to the SAP application. From here to here, there is a database, right? Why? Because SAP will depend on the database. SAP will depend on the database, right? Without database, SAP will not be alive. So SAP is the depend on the database. So these all are your user PCs. You will connect to the your SAP application server. All are logging to the different user accounts, different server, different ways. Different ways means so we can connect through SAP GUI or browsers. Through browsers also we can connect to the SAP application server. So this is the SAP, right? So this is the database. So this is the three-tier architecture. So which means these all are the presentation layers. Presentation layer means so your desktops, your laptops, your devices. So these all are the so presentation layer, right? Presentation layer. So this is the presentation layer. Presentation layer. So you are here, right? You are here. So from here through GUI or through browser, you will log into the SAP. You will do the transactions. You will do the other activities here. Then the data will go to the database level. It will store into the tables in the database level, right? Tables level. So now we are discussing about the this part, application layer part we are discussing here, right? Once this is completed, then immediately we will go to the DB layer, database layer, we will discuss here, right? So this is the so main thing here. So here, if I go a little bit deeply about SAP application side here. So whenever you install the SAP here, you will get the how many instances? Two instances you will get, right? One is the ASCS instance, and second one is the application server, one application server, right? One pass, which means so one application server. This is the ASCS, this is the pass, present primary application server. So it's application server. First we are installing, right? So it's a primary application server. Then when you install the second application server, this is the AAS, but both functionalities are same. The way we are speaking, that is the pronunciation is the different, but the only thing is the name is different, but the functionalities are same. Why? Because AAS is only one, DB is only one, but application servers may multiple also. Why? Because depends upon the load, we will keep on adding the application server. Suppose PAS, primary application server. In the primary application server, so we have dispatcher plus all the work process, right? Remaining 5 work process are available. Here, message server and queue server, right? DB, right? So we have, these are the work process are available in the systems. So normally, application server, normally in the SAP, when you execute the one transaction code, inbuilt, there is a business logic is means the code is mentioned. So the work is distributed among the application servers. So it quickly you will get the response from the systems. So database means database server. So it will store the data queries. So data we will retrieve the we will retrieve the data, right? So presentation layer and application layer. and database layer. Like that, we have the concept is available in the systems, right? So now let's talk about the this application layer. In the application layer, what exactly happens in the application layer? ASCS means when you are connecting to the ASCS, message server will take care of the request and will perform the load balancing and will assign to the request to the respective dispatcher, application server dispatcher, right? Respective application server dispatcher, right? So this will happen. Otherwise, when you are directly connecting, dispatcher will take care of the your request. So this is the way, right? So now, if I talk about little bit more about this architecture, like in this architecture, in this SAP application architecture, so what exactly here it will happen? What exactly happens here, right? So see here, let me. So this is the SAP GUI. Suppose same architecture I am giving here, SAP GUI. So this is the dispatcher. So same dispatcher, only this screen I am writing here. In just a little bit I'm elaborating here, right? So this is the dispatcher. So dispatcher, and this is the work process. This is the work process, right? This is the work process here. This is the work process here. So work process, all the work process are here, right? So then we have similarly, we have one more box come here, like role in user context box will come. Then after that, we have the buffers, application buffers are available here. Buffers are available here, right? So what I will do here, I will put a little bit small. Okay, a little bit small, so that all will be adjusted in the one screen. From here to here. So this is the role area. This is the role area. This is the buffers, application buffers, right? Application buffer, application buffer. Let me write app buffer. Okay, small. So app buffers here, right? Role area, application buffers, and here we have here we have, so this is the task handler here. This is the task handler. Then here we have the, so interpreters. We have the task handler and interpreters, task handler. Yes, task handler. And these are the interpreter process, which means screen processor, the screen processor. Then so above interpreter, so DI, database interpreter, right? Screen processor, above interpreter, database interpreter, right? So this is the one work process one. This is the work process, right? This is the one work process, either any work process, either the dialogue work process. Take the dialogue work process here, right? So this is the dispatcher here, right? This is the dispatcher. So this is the SAP GUI. This is the SAP GUI here, right? This is the SAP GUI. So normally, how our request is working here? Normally, how the request is working? See here in the system. See when you are in the SAP GUI. right? You are in the SAP GUI. So when you click on the button, immediately dispatcher will take care of the your request, right? Dispatcher will take care of the your request. See here, double click it, then immediately you will get the screen, right? You will get the SAP screen. You will get the SAP screen. How this is happening? Immediately it will assign to the one work process. So immediately it will assign to the work process. Suppose if I stop the dispatcher, what will happen? We will not able to log into the SAP system. We will not able to log into the SAP system because of you will not able to log in because of respective dialog work process are not available. So in any case, you are unable to log into the SAP system means there are no free dialog work process in the systems. So where can I check? What is the transaction code to check the status of the work process? Anyone can jump in. What is the
SM50.
SM50? SM50 is
50.
the transaction code to check the status of the work process here. So actually, in the dispatcher, dispatching the request to respective dialog work process, right? So dispatching the request. So what it will do? It will dispatch the request. It will dispatch the request to the to respective work process, right? Respective work process, right? It will dispatch the request to the respective work process. Then that work process in the each work process there is a internal mechanism that is called the task. It will assign the your request to the it request. One request will be allocated here. One request will be allocated here. One task will be created here. So one task will be created here. So when it go to the one task will be created. One task will be created. Immediately when I assign the task, immediately it will go to the so role area. Immediately it will go to the role area. Role area it will go. That is called the role in. We will call it as the role in. It will go to the role area. In the role area, it will in the role area there is a user context. There is a user context in the role area. There is a user context. User context means user ID, passwords related information are available here. Why? Because as a security checks, so here as a security checks here, the user ID password should check here, right? As a security checks, the user ID password should check here, right? So then it will check the from task handler to the role area user context is called the role area user context is called the role in process, right? Then here it will check, okay, whether that user is exist or not, it will check. Then if the user is exist, then immediately it will take care of your request. Immediately it will take care of your request. Immediately it will take care of your request. Then immediately it will take care of your request. Then immediately task handler will go and check the buffers. What is your logic, what is the transaction code you are executing, it will check in the buffers. Here the buffers are available. Buffers are temporary storage areas. The data, the transaction which are available, it will check in the buffers, right? If it is available in the buffers, then immediately it will check and immediately you will get the response from dispatcher to your GUI. Suppose example you can see here. So whenever I click the logon button, see here, click the logon button, immediately dispatcher will take and it will assign to the work process. Then here in the user context is asking the user ID and password. So if I enter one user ID, if I enter the user ID, suppose if I enter the user ID here, then click on button, then the password is wrong, immediately it will clear the directions. The password is wrong. In the user context, you will check it out here. Why? Because the request is going to the GUI to dispatcher, then dispatcher to so work process in the task handler. Task handler will assign the task to your request. Then it will check in the role area user context. So it will check the user is valid or not. Then it will send the response back to, so once the user is available, then he will be logged into the system. Then after that, it will check. So, okay, now you are using the wrong password. If I use the correct password, then you got the screen now. You got the screen now. So now you got the screen now. Here in this page, you got the screen now. So if you enter the logic here, suppose logic means I want to know the, suppose like RSA1, suppose example, one transaction code. Suppose like our ST22, whatever we discussed, right? If I execute it, immediately it will give the results. Why? Because so we are normally, so we are already using this all these transaction codes. That's why the data is available in the buffers. The data is available in the buffers. So in the buffers we have, so the buffers concept come. We have temporary storage data will come into the buffers. Temporary, the storage data will temporary storage, which means whatever the user is using in the application layer, buffers are there. So in the buffers, so whatever the screens you are accessing, those data already filled here in the buffers. So that's why immediately you are getting the response. So few transaction codes, it may take some time. Why? Because if you see here RSA1, if you execute it, it may take longer time. It may take longer time. Why? Because it may take a few transaction codes, it may take longer time. Why? Because those are the not related to the, those transactions are not related to the, not related, those transactions related data not exist in the buffers. So if you are not getting immediate response, then what will happen? It will, the task handler, it will check in the buffers. If there is no data, then immediately it will go to the screen interpreter. Then screen interpreter will go to the screen interpreter. Then we have about interrupt your screens, right? Then immediately it will go to the ABAP interpreter, ABAP code. Here code will be interrupted. The code will be interrupted here. The code will be interrupted here. Then database interrupter. Then it will assign to the database interrupter. So this database interrupter, it will go and pull the data from the database level. Suppose this is the database, right? So this is the database. It will go and pull the database from the database level. Database level, it will go pull it from the database level, right? So database level, this will go and pull the database level. So if the data definitely available in the database level, so that it may take some time. Why? Because instead of taking the data from the buffers, it is taking the data from the database level. So that then once the data is got it, then task handler will take it and will assign the one some data. It will be stored here. Why? Because it's a new data you are accessed. Then that new data is available. It will store into the application's buffers. Then it will send the request to the then above dispatcher. Dispatcher will send it to the user interface. User interface means this is your interface. Suppose I want to know, suppose if I execute one transaction code, then immediately it will go to the, so here response you are getting. So if there is no data, this will happen within fraction of milliseconds. You will get the things here within fraction of seconds. You will get the things here. Suppose if I use one transaction code, then this is taking some time. See here, why it is taking some time? See here, I executed one transaction code. Why it's taking some time? Why means here that the data which you executed, that is not available in the buffers. Then what happened? It will went to the database level. It will pull the data from database level. Then it will hand out the again a request to the your user interface. It hand out. So now same transaction code. Now if you execute now ST06, you will get the immediate response now. You will get the immediate response. So why? Because you will get the some response will be applied. Why? Because the same data will be while copying the data, same data will be stored into the buffers again. So that second time when you access the request, it will be fast. Second time when you will be accessing the data, it will be very fast. It will be very fast here, right? So this is about the our logon process, how the SAP logon process and architecture will be, right? So first you log in through GUI to, then when you double click it, internally dispatcher will take. Suppose example, let's see here. So where is our process? Dispatcher. Just stop the dispatcher here. What will happen? If we shut down the dispatcher, what will happen here? Right? I just stop at the dispatcher here, right? Then when you're logging, so which application server you connected here? That's first of all, that is important, right? 04 you connected, groups application server. So group you connected. So group you connected means, group application server you connected means, so it will assign to the respective, if the one application server is down, it will assign to the another application server. Okay, it will assign the request to the another application server. Even though the 10 is down currently, but so the 4 is available. The 4 is available. So it will route the request to the your 4, right? The fourth application server. So 4 is, suppose we'll stop 4 also here. I'm stopping the dispatcher here. All the application server, I'm stopping the dispatcher here. So dispatcher server down, right? So now what will happen? So when you click on the next button, when you log into the SAP GUI, then you won't log in here. See here, it is connecting to the SAP PRD system. Please wait. It is connecting. Even dispatcher is not taking your request. Why? Because here dispatcher down, right? Dispatcher down, immediately all work process also down. See here, the dispatcher down, the respective work process also will go down status. So down, see here, it's down. So which means no one, it won't take any request now, because dispatcher is the main process. It will assign the request to the respective so work process. Even this is down here. Even I logged out. See here, application server is down. Why? Because so all requests are down currently here. So down currently. Okay. So all application servers are down currently here. You can see here all application servers are down here. So which means so see here all application servers are down here. So which means you cannot log in now. You cannot log in as well. So suppose why means here the first is dispatcher will assign to the subsequent work process here. But dispatcher is not taking here. We stop at the dispatcher now. So now if you start it, just right click, the restart. Right click and restart. Right. So now you will connect it. Why? Because you have stopped it. And again you are starting the dispatcher. It's completely stopped. So now let's see. So again it stopped. Completely stopped. Okay, we need to do the restart once. Why? Because to flush out the memories and everything, right? So this is the way. So now what happened when you stop the dispatcher? Even you cannot log into the application layer, or because the dispatcher is the very important for the each and every layer here, right? Without dispatcher, you cannot log into the dispatcher. Dispatcher will take the request, will maintain the request in the order, FIFO order, first in, first out order. Dispatcher has one internal mechanism that is called the queue. So first in, first out mechanism. First in, the FIFO. First in, first out mechanism. It will maintain the request in the order. Then it will send the request to the respective available work process. Each work process, there is an internal mechanism, task handler. Task handler will take the request. It will check in the user context that user is valid or not. Then when you enter the logic, it will check in the buffers first. Okay, the data already exists in the buffers, it will give the response to you. If not exist, then it will go to the screen interpreter. It will interrupt the screens. Whatever the screen you are telling, it will interrupt the screens. It will compile it, above codes and everything. Finally, it will go to the database interrupter. It will take the request from the database level. Then it will give the response back to you. While giving the response back to you, one copy of data will save into the buffers. For the speed accessing purpose, it will save the data into the buffers. Right? So this is the way which we are. So our logon process is working here. This is the way, right? So this is the way our logon process is working here, right? So any questions from anyone here regarding the SAP architecture? No, I hope you got it, how the architecture works and how we are logging to the SAP systems and everything, right?
Ravi, one doubt.
Yes,
If there are two application servers
yes,
and one application server is down
yes.
and user is trying to connect to SAP, and a message server will assign that user request to
Another application.
available application server using
Yes,
load balance, or
yes. No, no,
it
no.
will try to connect to down server.
No. Down server it won't connect it. Why? Because when the application server is down, immediately, so immediately when the application server is down, immediately the application server will remove from the message server load balancing list. Immediately it will remove from the load balancing list. Okay, let me show you here. So in the OS level, if you see, suppose we'll go to the OS level or OS level USR SAP. So PRD, right? We have the multiple application servers, right? Work directory. So we have the, if you see the dev underscore ms, this is the main one. So if you see here, immediately there is no response from the client. There is no disconnected now. So why? Because it will try to assign it. If there is no response, immediately it will disconnect the application server from the logged on list, message server logged on list, which means it won't send anything to that application server. First, it will check it out. First, it will check 300 seconds. It will check by default. So whether that application server is available or not. First of all, 300 seconds it will wait. There is no, even though it is not responding, there is no response from the application server. It will wait 300 seconds. Then there is no response. Immediately it will disconnect. Immediately it will disconnect from the list. Immediately it will disconnect from the list. So that will happen. So when you something happened, immediately message server will log out the that 11th application server, 10th application server, it will give the logout. Logout means it will remove from this load balancing list. It will remove it. So when you are starting, immediately it will log in. Immediately when the application server comes to active in the SMLG, then immediately message server will take care of forwarding. Okay, this is available, active. Then I will have to forward the request to this application server also. Like that, it will assume it will send the request. It will send the request now. Now see, let me start here. Now you will get the things here. So in the same log file, you can see now. So it will update it now. Now log files will update it. Why? Because now system restarted, system started, right? It will update it, this one. It will update it. So basically, to answer your question, it won't forward request to the inactive application servers. So if it is forwarding to the inactive application server, means you are not direct you are directly connecting to the particular application server only, not to the ACS instance. When you are connecting to the ACS instance, it will forward the request to the respective app server, respective application server. It will forward to the respective application server. So if you are directly connecting, if this is down, how the message server will forward it, right? if you are connecting to the ASCS through group list, then only it will forward the request. Then only it will forward the request to the respective app server. Respective app server, it will forward the request to the respective app server. See here, immediately the 10th applications are in the login list. So like that, it will take it out again. It will again like that. It will start. It will take it the all the application servers list and everything. It will take it out. All the application servers. It will take it out. So this is the concept of the load balancing here. This is the concept of the load balancing here. So now we have discussed about the we are discussing about the buffers, right? In this one new topic, we have discussed about the buffers, like why what is mean by buffer here. We told that the temporary data will be stored into the buffers, right? The temporary storage will store into the buffers here, right? That is what we are discussing here, right? So buffers in the previous screen we discussed about the buffers, right? So this buffers and all, where can we see in the system means ST01. ST01, we can see the buffers. So our next transaction code is called the ST01. This is for the tune summary. Tune summary means here we can see the buffers, swaps, hit ratio, all these things we can see from here. All these things we can see, swaps, buffers. So all these things we can see in the system. So all these things we can change in the system. The buffer, swaps, hit ratio, all these things we can change it. All these things we can change in the systems here. So let me log in here. I think so 100 client is created. I think you can log into the 100 client here. Okay. Okay. So if you just use ST02 transaction code, you can see the tune summary. Here I told you, right, buffers we have. Buffers means we have table buffer, field buffer, program buffer, CA buffer, calendar buffer. So number of buffers are available. So here in the buffers, you can see the what is the free space, allocated space, free, how much free percentage we have, and the directory size. So all these things are available in the values here, right? So and also here you can see the hit ratio. Hit ratio, what does it mean by hit ratio? Hit ratio means when the request going to the buffers. So here, okay. Okay. So normally, so now let's discuss about the ST01. ST01. So this is the tune summary. ST01 is the tune summary. Tune summary. So here in the tune summary, what things we can see here in the tune summary? So buffers, swaps, hit ratio, SAP memory areas. So all these things we can see in the ST01 transaction code. So buffers. So what does it mean by buffers here? So what does it mean by buffers here? So when you see in the transaction SAP GUI, then it will go to the application server, then it will go to the database layer, right? So in the each application server, we have the buffers are there. Actually each application server we have the buffers. So screen buffer, so calendar buffer, CA buffer, so program buffer, so all the buffer. What does it mean by buffers means? So all the program related data will store into the program buffer, right? Screen buffer, calendar, so each and CA buffer, so tables related information, export import related information, so initial records related information, it will store into the so buffers. So actual data it will store into the buffers, one copy of data. So normally, if there is no data in the buffer, the request which you are searching, then it will go to the database layer, then it will search the data. So normally user request to go to the SAP buffers, it will check it out. Buffers, if there is no data, then it will go to the database layer. then database layer, it will pull the data, then give the response back to the buffers. It will store the one copy of data into the buffer. Then same data, it will be sent to the user request, right? So it will start from here, it will go to the here, then it will search it here, then it will. So while going to here and going to the here, maybe it may delay, it may take some time. Why? Because the first time you are accessing the transaction code, the transaction related data not available in the buffers, which means your hit ratio will be low. Why? Because hit ratio means hit ratio, the how many requests are hitting the buffers, pulling the data from the buffers. That is the hit ratio. So normally, as per SAP recommendations, the hit ratio, the buffers hit ratio should be 95 plus. It should be 95 plus. Those are the good performance. In the buffer hit ratio are the more than 95%, then it should be good. The ratio should be good, means the performance good. Why? Because everything is taking from the buffers. Then there is no use of going to the database level, pulling the data from here, then getting the here. Why? Because going to the here, it may take some time. Pulling the data, it may take some minutes. Then again, giving the response, it may take some time. Storing the data, it may take some time. Again, giving the response, it may take some time. So sometimes if you calculate it, the response time is very large here, right? So to avoid this type of things here, so if we have SAP, we have the buffers concept. So the first request, it may take time, but second request, the response will be very less. Why? Because one copy of data, the data is available here. So if you keep on accessing the data, you see today the percentage of the iteration is very bad here today, which means the response time is very bad here. All are below 90 only, right? All are below 95 only, which means it's a very bad. The ratio of the system is very bad, means system having some performance issues in the systems. So what does it mean here? So this is the free percentage, fine. What about the swaps here? Swaps means, so whenever the buffers, each buffer, there is a some, so percentage, some amount of memory is allocated, some amount of space, some amount of memory is allocated here, right? So if there is no free space, the overflow happens. So in your tub, in your bucket, the you released the tap, the water is pouring into the tap, one tub, one bucket, one glass. The quantity of the bucket is over 15 liters, the 15 liters over. So what happens? Remaining water, the new water which is coming, it will be, so it will be overflow, right? Overflow will happen. Is it correct or not? Right? So overflow will happen here. So then when the overflow is happening, so then here we will observe the swaps. When the swaps occurs means when the buffers does not have enough free space, then the swaps will occur. So suppose the buffer is full here, then copy of data here written, then again it's writing to the here, then there is no free space. Then the buffer, it says like overflow, which means the swaps occurs here. When the buffer swaps are occurring means the swaps are coloring, red coloring. When the swap occurs, it will give the red color. When the swaps are occurring means then your system, the buffers are getting full in your system. The buffers are, so the buffers are sitting in the buffers here. The buffer, the swaps buffers are sitting, data is sitting into the, so buffers, there is no space, then swaps will occur. The swaps may occur here. So that is the thing here. That is the concept of the, so thing here, right? Got it, right? So in ST01, we have a lot of information. So hit ratio, swaps, free, and you can also see the memory concept here, the memory concept here, SAP memory areas here, the page area, extended area, heap memory. There is a detailed discussion about this memory areas. So I will discuss with you, not now. So we will get maybe tomorrow or day after, depends upon the situation. I will discuss with you. So not immediately, like if I discuss with you, you will get confused. So depends upon the situation. I will discuss with you. So in any case, suppose swaps are occurring, then what you need to do? We need to check what are the objects are buffered, what are the objects are there here. If unnecessary objects, we can remove it. So if it's required, we can increase the buffer space, buffers free space also we can increase it. So if you see here, current parameters which are related to the buffers. So detailed analysis also we can take it out here. Suppose foreground buffer. If we go to the detailed analysis, so foreground buffer, we can see what is the allocated, available, used, and free. So each and everything you can see. You can also see the objects which are there in the buffers. In this buffer, what are the objects are there here? See, these are the foreground. This is the foreground buffer. It contains the foreground. See here how many foregrounds are there in the buffer. How many foregrounds are there in the buffer? You can see the all the buffers are available here. All the data is available here, right? Foreground buffer. Suppose you want to you want to increase the buffer parameter. Suppose like you can see the go to the current parameter. What is the buffer size here? Size of the foreground buffer. So then you can change it. Go to the RZ10 or RZ11. Then you can change the buffer parameter value. You can change it here. Buffer, the parameter value, you can change it in the systems. So go to the buffer. Then you can just go ahead and increase this value. You can increase it. Buffer size, you can increase it so that more objects will be stay here. So here, this is the not the dynamic parameter. Why? Because if the dynamic parameter, there is a change option will come. It's not the dynamic. So we have to change it in the RZ10 only. RZ10 is the transaction code here, right? Like that, we can see the history also. How many per day, how many swaps are occurring and everything. You will get the things here. How many swaps are occurring and everything. You will get the history also. History also, you will get it out here. So per day. So average on Monday. So how many days programs? So for days wise, the count will come here. The count will come here. So we can see if the buffers are there, then definitely we will get the results here. So if there is no buffers here, then we won't get anything here. So let's see in my other systems. Let's see if any swaps are there or not. So I have one main ECC production system here. So there the conversion is running. So conversion is running means the system is heavily loaded here. The system is heavily loaded in the ECC, my production system, right? You will also get work on this ECC production. Don't worry. Okay. So don't worry. Let's see here. So let me go to the ST01 here. When I go to the ST01, sorry, system trace, ST02. Tune summary. Okay. So 02 is the tune summary, not the 01. Okay. Here also there is no buffer. Why? Because today only I restarted. So all the data flushed out. So, but here you can see some values are minimum 90, 95 plus 98%, 97. So all are good. All are good. So all are almost good, except table initially. It will be increase it. It will increase it. So don't worry, it will increase it. So all are good now. Why? Because today only I taken the backup and I restarted. So it's fine. System is fine now. This system is fine. So ECP. So here, so last few days onwards in this system, the conversion related activities are running in the systems. Conversion related activities. So conversion related activities system is heavily loaded in the systems. System is heavily loaded here. Yeah. So I will also give the access to this system also, so that we can also get practice it here. System is heavily used here. System heavily used here in the system, so that you may get the experience on this area as well, right? So many jobs are running here, right? This is about the ST. So whatever we discussed, right? ST01, ST02 tune summary. ST01 is for the ST01. So ST, not the ST01. ST01 is for the tracing, right? ST02 is the tune summary. The buffers which we are discussing, right? That is the ST02. So ST01 is for the trace, system trace. Here in ST01, we can take that system trace here. ST01, we can take the trace. Trace means, suppose you want to trace something. You want to check the authorization error. You want to check the kernel issues, DB access issues, RFC calls, buffers, whatever you want to know some details about your request. In SM21, SM50, you are unable to get the more logs here to find out the root cause. You want to open some logs here. Then switch on the trace for the particular user. Then ask the user to reproduce the issue. Reproduce the means to access the system. Then he will face the issue. Then turn off the trace. Then do the your analysis. Do the analysis of the systems. So currently no records, nothing is there. Then it won't record anything here. It won't record anything here. This is the tracing concept. So system trace. In system, if any issues, so normally what we will do, we will go to the SM21. We will go to the SM21. Here we will see the logs, right? SM21. Here we will see the logs here, right? All the logs and everything we can see it here. So something time zone is not determined. Some jobs are getting failed. SOAP jobs are getting failed. So some collector jobs are getting cancelled, failed. So all the issues that we are getting. See here, logon step, job logon step user failed. So I want you to fix this error. Why? Why this job? Fix the error. This error. These jobs are getting cancelled in the system. These jobs are getting cancelled in the systems. Not sure why. See here, these jobs are getting cancelled. So why? These are the standard jobs. Why these jobs are getting cancelled? So logon step user in failed starting the step. So someone please fix this issue. Background jobs related information, right? So I can fix it right away, but I want you to fix the issue. Why it is happening here? Why there is a delay? Why the delay is happening? 21,000 milliseconds, 20,000 milliseconds. Why this is delay? Right? Normally it should supposed to start. When is it supposed to start? So 7:25 it should start, but 7:30 I think it started. Why there is a 5 hours delay happened? So this is 8:25 it should start. Then when it started, 8:25 when it started. See here, 1 o'clock, 5 hours distance, 5 hours or 5 hours, 4 hours gap, 5 hours gap. Why? I want this reason. Please investigate it. Okay, you investigate it and fix the error. Okay, today ST01 trace. I will give some information about the trace, system trace. So in the system, if you need more details, more logs, what is happening in the system. In SM21, ST22, you could not able to find out the more details here. Then you can just enable the trace in ST01. ST01, you can enable the trace in ST01. So you can enable the trace in ST01. Then so you can ask the user to reproduce the issue. Then user will check it out. All the information, everything he will check, right? He will check the trace and everything. So he will check. We can also save the trace also here. We can save it. So for records saved into the data. So records are saving. Okay. We can ask the user to reproduce the issue. Then you can do the analysis. You can do the analysis, what is happening and everything. See here, now logs are generated now. We waited for some time. See here, logs are generated. So what's happened here? You logged into the 100 client user ST01 transaction code. This is the transaction ID. Then when you start here, it's finished here. Then what is happened here? So all the information we got it. So why? What is the issue here? This is a call stack parameter, no duration at start of the action. So like that, you will see the error messages, right? So based on that, we have to investigate the issue further, right? What is this error and everything like that. So records are generated. So if I keep switch on the records with trace on, so it will create a lot of log file. That's why I switched off the log files. I switched off the log files here. Then when you see here, data will be getting more data, got it here. More data, you got it here, right? So this is the way we can switch on the tracer to get the data here. Normally in SM21, we can find out. So if you are unable to find out, not all the data will be captured here. Almost it will captured. But if nothing is there here, then you have the option to change the, go to the ST01 system trace. You can take it out here. Okay. This is the trace option. This is the tracing, right? ST02 is for the tune summary, buffers and everything. It's a tune summary, buffers related information. So buffer, sit ratio, free space, all this information we can see here. So what is happening here? What statement, select statement or insert statement or update statement at database level. So what is calls, everything, all the information we can see in the ST01 here. So memory areas, separately I will explain more here, SAP memory areas, right? The buffers, we have the buffers concept in the SAP side here. So detailed analysis we can see here. Summary of all the buffers here, we can see summary. All the buffers related summary we can see here, right? So all these things, buffers are the very important. The system performance is not good, it's very slow, means you need to come to the here, you need to check the buffers main, you need to check it out here, right? That is the main thing here. Okay, so that is the today's topics, right? The logon process, how the logon process works architecture wise, and also buffers related information and everything. So tomorrow what I will discuss with you, and remaining transaction codes ST034567, so 7, then so transport administration, like that it will go the flow, right? So what you have to do today,